All right. If you recall, when you first started dealing with fractions, and I do want you to write this down, so Sean, Pete, please grab a pencil and be writing. When we were adding and subtracting fractions, the rules were that fractions, in order to be added or subtracted, had to have a common denominator. And once you found that the denominators were the same, then you added the numerators, and what happened to the denominator? It stays the same. Nothing. The denominator was unchanged. So, 1/3 plus 1/3 gave you 2/3. Okay? Nothing changed in the denominator. You simply added the numerator. When we dealt with adding and subtracting variables, we said that before you could add them, they had to be common. Remember, we called them like terms or common terms. And once we identified that the terms were the same, then we added the coefficient. And what happened to the variable? Stayed the same. The variable was unchanged. So if we had 2a plus 2a, what did they give us? 4a. Okay, we didn't change the variable. It stayed the same. So today we're going to be adding and subtracting radicals. What do you think you have to be able to add or subtract radicals?
Same, like square or something.
Same radical. All right? When you're adding and subtracting radicals, you have to have a common radical expression. And once you've identified that it is the same, then you simply add the coefficient, which would be the big numbers in front, and the radical is unchanged. So if you look at what you wrote, basically we wrote the same thing 3 times, we just filled in the blanks with something different. Instead of common denominator or common variable or common radical, we said add the numerator, add the coefficient, add the coefficient. And then we said the denominator is unchanged, the variable is unchanged, the radical is unchanged. So you see the rules aren't changing, we're just applying them to different things. So what does that mean? 4 square roots of 2. If you were to add these 2 radical expressions, the name tag is square roots of 2. All right? Now, if there was no 1 in front of this, it's just like x. If there's no 1 in front of x, it's understood that there's 1, correct? If there's no number in front of a radical, it's understood to be 1. Yes, they are the same. They are both the square root of 2. And what's 1 plus 3? 4. So the answer to that is simply 4 square roots of 2. When we're working with radicals in this class, you are not going to be punching this into a calculator and giving me a decimal answer unless I specifically say to. All right? You will have to learn how to manipulate the radicals and use them in this way. If I get a decimal answer, I'm counting it wrong. Did everybody hear that? Okay, you've got to learn how to do this. These are 3 terms. Are they all alike?
No.
Are any of them alike?
Yes.
Yes. 2 of them are the square root of 3. Now, if you say it this way, it's very simple to add it together, but we have 4 square roots of 3 plus 5 square roots of 3. It's like saying 4 trees plus 5 trees. Well, what do you have? 9 trees, or 9 square roots of 3. Well, what do you do with that extra one? Well, it still needs to be subtracted, but we're not actually going to subtract it because we can't, as it is. And you're not going to plug that into a calculator and figure out the decimal answer because that's all you can do at this point. And I don't want a decimal answer, okay? From here, you stop. They're not the same, different radicals. Now what do you think happens? You got to reduce. Okay, now we're taking yesterday's lesson where we learned how to take each individual one of these and reduce them. So we're going to reduce first, and then we might find that there are actually common terms here. All right, well, let's take 12. Remember, we're going to break this down to a product of its primes. What is 12? It's 4 times 3, and 4 breaks down to 2 times 2. All right, which means that I have 2 squared under this square root, so what can come out of here? A 2, and I still have a 3 left underneath. All right, now let's look at this second term. 48 reduces down to 6 times 8. All right, when you do this, I do recommend you check your multiplication. Make sure that you do get 48. Because you might throw an extra 2 in there or not have enough 2's. Okay? All right, well, what do I have here? I've got 2 groups of 2 there, so I can pull out 2 squared, which is 4. And I still have a 3 under the radical. And now let's look at 27. 27 is 3 cubed, is it not? Okay. Well, I have one pair or one group of 3, so I can pull out 1 3. And I still have a 3 left under the radical. Okay. Well, now look. Those are alike. They are all alike. They're all a square root of 3. The answer is going to have square root of 3 in it. What am I actually adding? 2, 4, and negative 3. 2 plus 4 is 6, minus 3 is 3. And that would be your final answer. So we're combining what we learned yesterday with what we learned in like 5th grade. We're just applying it now to radicals instead of fractions. All right, here we go. Square root of 3 plus the square root of 72 minus the square root of 128 plus the square root of 108. I want you to work on this one yourself. Okay. Square root of 3 can't be simplified any more than what it is. 72 is 8 times 9, right? 128 is 4 times 32. 32 is 4 times 8. Okay? And 108 is getting small, because I'm running out of room here, is 4 times 27. Okay? A little crooked. Sorry. All right, so here we're done. This is 1 square root of 3. Plus, I have a group of 2's, so I can take out a 2. And I have a group of 3, so I can take out a 3.